Rockets need an incredible amount of energy to get to space. Where do they get energy from and how do they harness it? My name is Ronny, and my name is Ronny, and we're going to teach you about chemical rocket propulsion. The defining characteristic of a chemical rocket engine is that it uses chemical energy to produce thrust. Two chemicals, a fuel and an oxidizer, are mixed in the engine where they react violently, releasing lots of energy. How does this energy get turned into thrust? Well, the typical rocket engine is made up of two parts, the combustion chamber and the nozzle. The combustion chamber is where the two chemicals are ignited to form superhot gases. The converging section of the nozzle funnels the superheated gases to the throat, which is the narrowest section of the nozzle. The throat is an important piece of the nozzle because it chokes the gas flow and allows pressure to build in the combustion chamber. The diverging section of the nozzle is also very important because it makes the gases that leave the combustion chamber expand directly away from the rocket engine. Without the diverging section, the gases would expand in a wider cone, drastically reducing efficiency. The reason thrust is produced by this is described by Newton's third law, which states that for every action there is an equal and opposite reaction. Think of a rocket engine like this balloon. When I let it go, it produces thrust and propels itself across the room. The big round part of the balloon is like the combustion chamber. The stretched material pushes in on the gas inside it, creating a higher pressure than its environment. When you let go of the balloon, the air accelerates from the higher pressure region to the lower pressure region, and an equal amount of force acts on the balloon in the opposite direction, propelling it forwards. When things heat up, they expand. In a chemical rocket engine, the gases are heated in the reaction, causing them to try to expand, but since the combustion chamber is made up of strong, rigid material, an immense amount of pressure is produced instead. And how does the nozzle come into this? Well, the nozzle from a chemical rocket engine serves a similar purpose to the nozzle one would use for a garden hose. Without the nozzle, the water comes out at a relatively slow speed, and with the nozzle, the water is substantially accelerated, making it reach farther. The faster the fluid comes out, either in a hose or in a rocket engine, the more thrust it produces. A garden hose can even produce enough thrust to lift itself off the ground, almost like a real rocket engine. Now, I believe there are two types of chemical rocket engines generally used in the space industry, solid and liquid-fueled engines. That's right, liquid-fueled rocket engines use liquid fuels and oxidizers pumped into the combustion chamber at high pressures. These engines are advantageous because they can be turned on, off, and back on again with the use of valves. However, they are very expensive because of the complex pumps and fluid systems involved. Solid-fueled rocket engines use a mix of powdered fuels and oxidizers, usually held together by a binder, a glue-like substance that is generally also a secondary fuel. This mix is cast into the engine casing. When ignited, it burns until it is used up. You cannot throttle or turn these off once they're on. So basically, chemical rocket engines use the energy stored in chemicals to generate superhot gases at high pressures, which are then expanded directly away from the rocket to produce thrust. Yup, my name is Ronny. And my name is Ronny. Thank you for watching. We hope you learned something new today.